Welcome to the Chapter 8 Part 2 video where we're going to be taking a look at ellipses and circles. So why do we care? Ellipses are the paths of planets and comets. I kind of mentioned this last class. Whenever an object enters a gravitational field, its path will follow that of an ellipse or occasionally a hyperbola. So again, conic sections. An ellipse is defined geometrically as a set of all points whose distance to two fixed points is a constant sum. So this is different from a parabola. Remember a parabola, we had a point and a line, and we looked at all of the points that were halfway between the point and the line. Any point that was the same distance ends up on our parabola. For an ellipse, we have 2 points. And now for the distance, we're adding up the same distance. So think about like a piece of string attached to 2 nails, and then all of the places that that string can reach. Something like this, and all of those points will lie on an ellipse. So for an ellipse, we have 2 points, so now we have 2 foci. Okay, the foci are along what we call the major axis or the focal axis, and the center of our ellipse is halfway between the foci. So the center of our ellipse is halfway between the foci, and the foci are the 2 points, like the nails, that the distance from those points to the circle always adds up to the same number. Okay, when we look at the vertices now, we're looking at the points on the edges of the focal axis of the ellipse. So we have similar vocabulary to the last section. We have the vertices. Okay, we have a center now. That's new. And we have now, instead of 1, we have 2 foci, which is the plural of focus. Okay, now we have a special case for a circle, and we've seen that a circle has only 1 center, and all of the points are the same distance away, and we call that distance a radius. And the way we get a circle from an ellipse is that the foci equal the center, and so we have kind of all 3 points lined up on top of each other, and that's what makes an ellipse into a circle. Okay. So this is a much cleaner drawing of what I just drew. We have the center, we have 2 foci, a focus on each side of the center, and then we have 2 vertices, a vertex on each side of the center. Okay. We have, again, a table of kind of formulas that we can obtain from looking at our picture. So I'm going to draw it here again. If we have our center, our foci, our vertices. Okay, so if this center is at 0, 0, then our focal axis will be the x-axis. The foci are a distance of c from the center. So that distance of c we'll obtain by looking at our distances that we kind of defined in our first class. We have our longest distance a and our shorter distance b. And the distance c is actually, if a was a hypotenuse and b is a leg, then c is the other leg. So we actually can set up a Pythagorean relation where a is the hypotenuse and b and c are the legs. And that's how we'll get this value for c. We have a is called our semi-major axis, the longer one. Major is bigger. And then we have b is our semi-minor axis. Why are they semi? Semi means half. So if I look at my ellipse, all the way across would be 2a. So halfway across is a. The whole way across would be 2a. And then the same thing if we look at our ellipse and we look at our minor axis, the whole way across is 2b. So halfway across is b. And we can do all of those same things for a vertical ellipse. If I have a vertical ellipse, I can say, here's my center, here are my foci, here are my vertices. The distance from center to vertex is a. From center across perpendicular is b. The distance from the center to the focus is c. And again, we have that same relationship where a, our semi-major axis, is the hypotenuse of B and C. Okay, so that's how we will find a C value or use a C value if the focus is given. This kind of goes into that Pythagorean relation a little bit more, where we have C is our focus, 0, C, and C, 0 gives us our focus. And the way we can calculate that if we're given the axes is the Pythagorean relationship that this side, or the semi-major axis, distance A, is also equal to the hypotenuse from the focus to the semi-minor vertex. So this was a vertex, vertex, focus, center, focus, and then these points don't have a name that is commonly used, but we can call it a minor vertex or a semi-minor vertex, depending on kind of how you're visualizing it. Those are the 2 points on the ellipse that intersect the minor axis, the non-focal axis. Okay, and again, the same thing applies whether the ellipse is horizontal or vertical. So let's look at applying some of this. We want to find the vertices and foci of an ellipse, and we are given just the equation. So the first thing to do, we saw this in our practice, is we want to set this up into our standard notation. And to do that, we want to set it equal to 1. So we're going to divide everything by 36. So we get x squared over 9 divided by 36 is 4, plus 4 divided by 36 is 9, equals 1. Okay, the bigger one is a. So this is a squared and this is b squared. Because my a squared is underneath y, I know a is bigger than b. And since a squared is under my y squared, I know that this is a vertical ellipse. I'm going to draw that a little bit better. Okay, center, to find the center, I want h and k. We haven't even really talked about h and k yet, but we know that they would be attached to the x and y. So I know that my center is 0, 0. Okay, a is my major axis. A squared is 9, so a is 3. 1, 2, 3. 1, 2, 3. B is the minor. B squared is 4, so B is 2. 1, 2, 1, 2. Okay, so from 0, 0, if I go 2 to the right, I'm at 2, 0. If I go 2 to the left, I'm at negative 2, 0. If I go 3 up, I'm at 3, 0, and 3 down. Sorry, I did that backwards. I'm at 0, 3. And 3 down, I'm at 0, negative 3. Okay, so I found all of my points, but which 2 are the vertices? The vertices are the ones on the major axis or the focal axis. So my vertices are 0, 3, and 0, negative 3. Now I need to find the foci. The foci are the ones that are kind of on that same axis, but inside of my ellipse. And in order to find that, I need to set up my Pythagorean relationship. So I can see that my base is 2, my hypotenuse is 3, and I need to find C. So I can say 3 squared equals 2 squared plus C squared. 9 minus 4 is C squared. 5 is C squared, so C is the square root of 5. So this point is 0, comma square root of 5, and this point is 0, comma negative square root of 5. Foci, 0, root 5, and 0, negative root 5. Okay, so we used our formula, our standard form for our equation, to break it down and find A, B, and C. For a parabola, we had P, H, and K. We're going to look at H and K for ellipses as well, but now we don't have P, we have A, B, and C. Okay, so let's look at another example. This time we want to find the equation. We're given the foci, and we're given a minor axis with a length of 2. Now be careful, because remember, B is our semi-minor axis. So that means our minor axis with a length of 2, that goes all the way across the ellipse. That means B is 2/2, or 1. Okay, so foci, again, we're looking at centered at 0, 0. We haven't introduced our translations yet. So if I have a foci at -2 and +2, comma 0, let me sketch that. I've got 2, -2, and a minor axis with a length of 2 all the way across. Okay, now our ellipse does not go through the foci, it goes around the foci. So this is what our ellipse will look like. We do know we have our triangle here, so we can find our major axis length. We have 1, 2, A squared equals 1 squared plus 2 squared. A squared is 5. A equals, coincidentally, the square root of 5. So we know that our point here is at the square root of 5, comma 0. And our point here is at negative square root of 5, comma 0. But what we want is our equation. Now we needed A for the equation, but we don't really need to find the vertices. I'm just trying to put everything together. So our equation, we have x squared plus y squared over our values equals 1. Our major axis is the x-axis, so our biggest number, our A, is going under the x. That's the square root of 5 squared. Our minor axis, which has a length of 1, goes over y. So this becomes x squared over 5 plus y squared over 1 equals 1. We don't have to write the over 1, but I'm going to leave it so that we can see how it's in the form of our standard equation. Okay, so we didn't need to find C in order to solve this, but we were given C and we needed that to solve A. I need to be given either A and B, B and C, or A and C. I have to be given 2 out of the 3 values in order to finish solving it, or the graph or the equation, which will give us 2, at least 2 of the 3. Okay, so now let's look at translations. So if our center is not 0, 0 now, the only thing that changes is that everywhere there's an X, there's also an H. Everywhere there's a Y, there's also a K. Okay, so our equation now, we have HK giving us our center at H, comma K. We have H and K added to all of our coordinates. Okay, and that's really the only things that have changed. Our focal axis doesn't have to be the y-axis anymore. It could be y equals k, which is still a vertical line. Okay, sorry, a horizontal line. And then the same thing for our vertical ellipse. Nothing has changed except for where we've centered it. So we have HK in the middle. We still have our foci and our vertices, and then our minor axis. Let's look at examples. Again, this is something you should have in your notes. Remember I said to have one place in your notes with all of the kind of tables of values. Wherever you have this table for parabolas, I would put the same table with center HK for ellipses so that they're easy to refer to. So make sure you're labeling it, which one's for parabolas, which one's for ellipses, and then you'll need one for hyperbolas as well. So our diagram, cleaner than the one that I drew. Everything is the same, right? We have our minor axis and our major axis. That's what makes the cross. And really what we're thinking about is that set of axes has been translated or moved, shifted from our X and Y axes. Everything else is the same. We have our center, our foci, and our vertices. So our example 3 here, find the equation of an ellipse. Find the standard form for the equation of ellipse whose minor axis endpoints, that means it's the small one, are at -1, 4, 5, 4. So that means this distance is 6. The center will be halfway between it at a distance of 3. And whose major axis has a length of 8. That means going up and down a total of 1, 2, 3, 4, 8 units. Okay, that wasn't very evenly drawn. 1, 2, 3, 4. So now we have our ellipse, and I didn't draw it very much to scale, but essentially this distance is 4, this distance is 3, okay? And we need the equation of the ellipse. So we need to know where the center is. Okay, so the center was at 1, 2, and up 4. So HK equals 2, 4. How did I find that? Well, I know I'm going from the endpoints of the minor axis, and I'm finding halfway between those. So you can find the midpoint of these points. I should say the midpoint of the segment formed by these points, if I'm being precise. And I should be. Segment from these points. Okay, so we have HK, I have A and B. A is my major, so A is 4. B is my minor, so B is 3. And now I have everything I need to form my equation. So I have x minus 2 squared divided by, and I always do the denominators last, x or y minus 4 squared equals 1. Which one is my major is A, and A goes up and down, so it goes underneath y. So 4 squared is 16, and B squared is 9. The 3 goes sideways like the x-axis, so 3 squared goes under x. The 4 goes up and down like the y-axis, so 16 goes under y. Okay, it might be helpful to have graph paper. I have a resource where you can print your own graph paper on the topics page called Helpful Resources. So if you don't have graph paper and you want to use some, this is one of the sections that will be really helpful. Okay, example 4. Locating key points of an ellipse. So we're doing that same thing backwards. I'm given the equation. I want to find the center, vertices, and the foci of the ellipse. So I'm going to look at this and I'm going to, again, sketch a quick graph. I know that h is -1 because this is minus h. K is 1, so I can graph -1, 1 is my center. My bigger number here is 9, so I know that A is 3. 1, 2, 3. 1, 2, 3. And then my smaller number is 4, so that means that B is square root of that, which is 2. 1, 2, 1, 2. So really, without doing much calculation, I can find these points. My center, which is HK, is -1, 1. Let's go vertices next. Vertices, which are the major axis, so the one that was longer, the vertices are here and here. So that's going to be -1, 1, 2, 3, 4, and -1, down 2. You can double check this, the midpoint of the point halfway between those 2 points should be HK. So I have -1, 4, and -1, 2. Okay, now what I'm missing are the foci, because the foci are not from my minor axis, right? My foci come from C. So I need to know, I have B, I have A, and I need C. C squared plus 4 equals 9, minus 4, C equals the square root of 5. So again, the answer is not always going to be the square root of 5, but I'm using the same numbers so that we can kind of see how these are related to when we were doing it with 0, 0 and when we're doing it with HK. Okay, so here I have -1, C, -1, 1, plus and minus the square root of 5. -1, 1 plus the square root of 5, and -1, 1 minus the square root of 5. Why is that? Because from the center, I go a distance of square root of 5 up and a distance of square root of 5 down to find my two foci. So there are my critical points. Okay, that's it for this section. Again, we'll do more practice in class, and then you'll have a math Excel as well. So if you have any questions, feel free to email me or write them down so that you can remember to ask them in class.